Today we are going to look at a very important topic in calculus, which is what? Limit. And let's look at limit. We are going to solve more problems on limit. And let's look at question number 1. Number 1, they say we should evaluate the limit of 3x squared plus 3 as x tend to what? 0. Now we want to evaluate this limit of 3x squared plus x as x tend to 0. How are we going to evaluate it? Let's look at it. Solution. If you look at this limit, it's a direct limit as x tends to 0. That means the limit of x 3x squared plus 3 as x tends to 0, right? As x tends to 0, it's telling us that now anywhere we see x, we should do what? Substitute what? 0. That is what it means. As x tends to 0. Anywhere we see x, we should put what? 0. So we are going to have 3 bracket 0 square plus 3. You know that 0 square is what? 0. 0 times 3 is what? It's equal to what? 0 plus 3. So 0 plus 3 is what? It's equal to what? 3. And this is the final answer. The final answer is what? 3. Don't forget that. This is how to evaluate this limit. And this is a direct limit. That's how to evaluate it. Now let's look at the second example on limit. The second example on limit. He said we should evaluate the limit of what? X squared minus 4 all over x minus 2 as x tends to 2. As x tends to 2, look at this. What they are telling us is that when x goes to 2, that means anywhere we see x, we should put what? 2. But if we check at this function that is giving us here, you see that if we put 2 here, we're going to have 2 raised to the power of 2 is what? 4, right? 4 minus 4 is what? 0, right? If you put 2 here, we're going to have what? 2. 2 minus 2 is what? 0. We're going to have 0 all over 0 if you use direct method. So we are not interested in getting 0 at this particular point, because this function is a difference of 2 square. So how are we going to solve this guy? We are going to use expansion method of solving this question. So let's look at how to solve it. Solution. Please pay attention. This question is very vital in calculus. Now let's look at it. We have the limit of what? The limit of x squared minus 4 all over what? X minus 2, right? As x tends to what? As x tends to 2. Now, if you look at the question, we see that x squared minus 4 is in form of what? Difference of 2 squared, right? Which is the same thing as what? This is the same thing as what? The limit of x squared is what? We are going to have bracket x minus what? 2 bracket x plus what? 2. This thing, when I expand this guy, the first one, the denominator, when I expand it, I'm having what? X squared minus 2 bracket x plus 2 is going to give us the same thing here. That is different of 2 squared. Now, all over this guy here, we have what? We have what? X minus 2, right? As what? X tends to what? 2. As x tends to 2. Now, pay attention. As x tends to 2, we can now use direct method and substitute this guy into the function. So let's look at how to substitute it into the function. Now, before we substitute it into the function, we know that this denominator, x minus 2, can cancel this x minus 2 at the denominator, which is this guy, cancel this guy, right? Do you understand? Okay, that's good. Now, we know that this guy cancel this guy, so we are going to let what? The limit of what? The limit of what? We are going to have let the limit of what? X plus what? 2. As x tends to what? 2. As x tends to 2. So as x tends to 2 now, what are we going to do? We put 2 where we see x. So we're going to have what? Now we have as x tends to 2. This is 2. We'll take note. This is what? This is 2. As x tends to 2, we put direct by direct method. When we see x here, we do what? We put 2. So we're going to have what? 2 plus what? 2. And our final answer is what? 4. This is how to solve this kind of what? Problem in calculus. I hope you understand. Okay, thank you very much. Let's move on to the third example Look at the third example on this limit of a function. They say we should evaluate this limit. The limit of what? 3x squared plus 5 all over what? 2x squared minus x. As x tends to what? Infinity. This symbol means what? Infinity. As x tends to infinity, how are you going to evaluate this limit? Let's look at it in a proper way. Solution. Now, if you look at this guy, what are we going to do is that as x tends to infinity, we do not know the particular limits. So since as x tends to infinity, what we know that as s is going to infinity is tending to what? 0. So our s will be what? 0 at this case. But before then, we are going to divide each of the terms by what? The highest power. By the highest power. You know that the highest power of s here is what? Is 2. The highest power of s here is what? 2. Yeah, the highest power of s is what? 1, right? It's 1 here. So we are going to divide both the denominator and the denominator by the highest power. Let's try to get this particular question in limit. So let's look at it. So we're going to have the limit of what? The limit of 3s squared. Our highest power from this function is what? S squared. Because s squared is greater than what? S to the power of 1. So we're going to divide each of these functions by what? S squared. So we're going to have s squared, 3s squared rather, divided by what? S squared, right? Plus, now we have 5x. 5x divided by what? S squared. This is denominator, right? Then all over, we have our 2x, right? Our 2s squared rather. Our 2s squared we divide by the highest power, which is what? S squared. Now we come to here minus x. Minus x divided by the highest power of x, which is also what? S squared, right? And we know that what s is tending to what? As s is tending to infinity, I said earlier that as s is tending to infinity, it's tending to what? 0. So now our s is tending to what? 0, right? Take note of this. Now let's look at it how to eliminate some of the function or some of the terms that are the same. You know that s squared cancel s squared, right? So s squared cancel s squared. We are going to have what? This is going to remain what? Limit of what? S squared cancel s squared. We have what? Limit of 3, right? Now we come to this side. There is nothing to cancel because there is no x here on the denominator. So we're going to have 5 all over what? S squared still on the denominator. All over. You come to this side. You know that s squared cancel s squared, right? This is our 2 rather. S squared cancel s squared. S squared cancel s squared. We go to left with what? 2. Now we come to this side. Minus. You know that s cancel what? S go here 1, S go here what? 1. So we're going to have what? 1 all over what? X, right? As x tends to what? 0. As x tends to 0. Do you understand? Okay, that's nice. As x tends to 0. Now, what we're going to do now is that anywhere we see x, we put what? 0. So we're going to have this become what? 3 plus 5 all over what? 0 square, right? You know that 0 square is the same thing as 0, right? For the denominator. All over. You come to the down side, you see I got 2 minus 1 all over what? 1 all over what? Our s is what? 0, right? That's good. Now, this becomes what? Equals to. You have what? 3. You have 3 here, right? 5 divided by 0 is what? 0, right? That is 3 plus what? 0. All over, come to the down side, you have 2 here, right? 1 minus what? 1 divided by 0 is what? 0. So we're going to have what? Our final answer become what? 3 plus 0 is what? 3. 2 minus 0 is what? 2. Therefore our final answer is what? 3 all over 2. Please pay attention to this solving. 2 all over 3 all over 2. That is our final answer for this function that was given to evaluate. Thank you very much. Let's look at the fourth example on limit. They say we should evaluate the limit of what? Sine x minus what? X all over what? S cube. This is 3 s cube, right? As x tends to what? 0. Pay attention. This is another important question that always comes out in the exam. You need to know this question. They say we should evaluate the limit of what? Sine x minus x as x tends to 3. How are we going to evaluate it? If you use direct method, you're going to give us 0, which you are not interested in getting that now. If you say sine x, sine 0, if you put 0 where x is going to give you sine 0, and sine 0 is what? 0, right? Minus, if you put 0 where x is what? 0, right? So 0 minus 0 is 0, right? Now you come to the denominator, you put 0. 0 cube is what? The same thing as 0. So we are not interested in solving it and getting 0 at this point. So what are you going to use? You use what they call an hospital rule to solve this question. So because of that, we use what they call what? An hospital rule. To solve this question. What does this thing mean? And hospital rule is telling us that we should differentiate both the numerator and the denominator until we have it that the denominator is not what? 0. So let's look at it, how to get it. Now we are given that the limit of what? The limit of sine x, right? Sine x minus x all over what? S cubed as x tends to what? 0. Now, for us to be able to achieve this by making it not to be what? 0 in the denominator, what we are going to do is to differentiate both the numerator and the denominator until when we substitute this x now as 10 to 0, we are not going to get what? 0. So let's look at it. If you differentiate sine x, what are you going to have? We have what? First differentiation, you have what? Cos x. If you differentiate sine x, you are going to have what? Cos x. If you differentiate x, we are going to have what? 1. If you don't know how to differentiate, I will advise you to go through my channel. You see how to differentiate a function. But this is not our study topic today, so you can go through the channel and check it. Now I differentiate the denominator. Now let's differentiate the downside, the denominator. If you differentiate x raised to the power of 3, what are you going to have? We are going to have 3x squared. Because this power is multiplied the function and you subtract 1 from the power, that's why you have 3x squared. Now, as what? As the limit of what? The limit of what? X tends to what? 0, right? Now, at this point in time, if you put 0 here, you are still going to get 0 in the denominator. So you still need to differentiate this guy. So let's differentiate secondly. We have cos x. If you differentiate cos x, you're going to have what? Minus. You're going to have what? You're going to equal to what? The limit of what? If you differentiate cos x, you're going to have what? Minus what? Sin x. If you differentiate 1, what are you going to have? It's a constant. So if you differentiate a constant, it's 0, right? So this is going to be what? 0. All over. If you differentiate this guy, 3x squared. This 3, this 2 now you're going to multiply this 3. Give us what? 6x. Then you subtract 1 from the 2. You're going to have what? The same raised to the power of 1. Now if you substitute as x tends to what? 0. You're still going to get 0 in the denominator. So we are not interested in getting 0 now. So we differentiate again the third differentiation of this function. The limit of, if you differentiate sine x, what are you going to have? You're still going to have what? Cos x, right? But there's minus here. So you're going to have minus cos x. Minus cos x, right? This is already what? This is 0. Minus cos x. Now it comes down. If you differentiate 6x, what are you going to have? You are going to have what? 6. Because there's an invisible one here. The power 1 multiply this 6x, going to give us what? 6x, right? Then 1 minus 1 is going to give us 0. And anything raised to the power of 0 is what? Is 1. We are going to have s raised to the power of 0, which is what? 1, based on the law of indices. So our denominator becomes 6. And we know that s tends to what? 0, right? Now you can substitute this guy into the function. So if you substitute as s tends to 0, what are you going to have? You are going to have minus cos what? 0, right? All over what? 6. Cos 0 is what? Cos 0 is 1, right? But we have minus here. So you're going to give us minus 1 all over the 6 here. So as final answer becomes what? Minus 1 all over 6. Please pay attention to this solving and put it one after the other. Solve it by yourself to get more clear understanding of it. Thank you very much. Let's look at the fifth example. On this, the fifth example So you should evaluate the limit of what? Exponential is power of x minus 1 all over x as x tends to 0. Please pay attention to this. Evaluate the limit of what? Exponential is power of x minus x as x tends to 0. If you use direct substitution method, you are going to have 0, because if you say 0 is power of this exponential, you're going to give us 1 and anything is power of 0 is 1, right? 1 minus 1 is 0, right? If you put 0 here, it's going to give you what? It's going to give you 0. 0 divided by 0 is going to give you what? 0, right? So we are not interested in getting that particular answer now. So let's look at how to solve this guy. Solution. Now we have the limit of exponential is for x minus 1 all over what? X. As x tends to what? 0, right? As x tends to 0. Now in this case, what we are going to do is to do what? Derive each of these functions by Reynolds-Hospital rule, by L'Hospital. Reynolds-Hospital rule, right? We are going to differentiate the denominator and denominator until when we substitute this limit as x tends to 0, we are not going to have 0 in the denominator. So let's look at how to do it. If you differentiate exponential x, we are differentiate each of the 10. If you differentiate exponential x, what are you going to have? Exponential x is the same thing as what? Exponential x when you differentiate it. Now if you differentiate a constant 1 is 0, right? So that has gone. All over, it comes down here. If you differentiate x, it's going to give us 1, right? Exponential x all over 1 is going to give us the same thing as what? The limit of what? Exponential x, right? You know that x tends to what? 0. Now, as x tends to 0, we have exponential x, right? Now we're going to substitute 0 where we see x, because x is tending to 0. So we're going to have, this is going to give us what? This is power of 0. And based on law of indices, anything raised to power of 0 is what? It's equals to 1. And this is the final answer. Thank you very much. I really appreciate the fact that you are here, and this is a very good channel for you to learn mathematics and other science courses. So if you are not subscribed to this channel, I will also ask you to do so that I can get more notification when I upload new video. Thank you very much. Do well to subscribe to this channel, like the video, and share it to your classmates and those in need of mathematics. Thank you very much. God bless you.